What if the universe isn't the beautiful, peaceful expanse we imagine it to be? As we gaze up at the star-filled night sky, we see a canvas of tranquility and wonder. But beyond that shimmering veil lies a reality far more unsettling than we've ever dared to conceive. We are about to journey into the dark side of the cosmos, where breathtaking beauty gives way to terrifying phenomena that defy our understanding of reality itself. Imagine a place where stars can devour their own planets, where invisible forces tear space-time apart, and where entire galaxies silently vanish into nothingness. This is not science fiction, this is the chilling truth hidden within the vast, silent darkness of space. For centuries, humanity has looked to the stars with a sense of wonder and hope, but what if that hope is misplaced? What if the universe is not our friend, but something indifferent, even hostile? Today, we're pulling back the curtain on 25 of the most terrifying space horrors ever discovered, phenomena so strange and unsettling that they challenge everything we think we know about existence. From black holes that warp reality to rogue planets wandering the void without a sun, from cosmic voids where nothing exists to mysterious signals that hint at intelligence beyond our comprehension, each of these discoveries pulls us deeper into the enigma of the cosmos. You are about to embark on a journey that will leave you questioning the very nature of reality. This is not just a list of facts, it's an exploration of the universe's darkest secrets, a descent into the unknown that will forever change how you see the night sky. So prepare yourself, because what lies ahead is both awe-inspiring and deeply unsettling. The universe is far stranger and far more terrifying than we've ever imagined. Let's begin. We begin our descent into the cosmos's shadows with a force so immense it is literally dragging our entire galaxy through the void. Imagine you're in a boat on a vast, calm river. The water seems still, but you slowly realize you're being pulled by a current you cannot see, moving toward a waterfall whose roar is still too distant to hear. This is our reality. Our Milky Way, along with every galaxy in our local group, is caught in this irresistible flow, moving at an astonishing 14 million miles per hour toward a point in space we cannot even see. Astronomers call this the Great Attractor. The mystery of this phenomenon is magnified by its location. It lies in the direction of our own galactic center, a region known to astronomers as the zone of avoidance. From our vantage point on Earth, this area is shrouded by the thick gas and dust clouds of the Milky Way's central bulge, making it nearly impossible to observe with traditional telescopes. It's a blind spot in our vision of the cosmos, and hidden within it is a gravitational anomaly with the mass of tens of thousands of galaxies. For decades, we were essentially being pulled toward a cosmic blank spot, a terrifying question mark in the sky. What could possibly possess such unimaginable gravitational power? The leading theory suggests it is not a single object, but an immense concentration of mass known as a gravitational anomaly, likely a vast supercluster of galaxies. Yet even that may not be the full story. Some scientists speculate it could be the heart of an even larger structure, a junction point in the cosmic web where the filaments of the universe meet, creating a gravitational sink from which nothing can escape. The sheer scale of this force challenges our understanding of the universe's structure, hinting at hidden layers of reality governed by laws we are only beginning to grasp. The ultimate fate this force holds for us is perhaps its most haunting aspect. While the journey will take billions of years, the destination is a profound unknown. Will our local group of galaxies be merged into a colossal, chaotic mega-galaxy, stars and systems thrown into disarray? Or is the Great Attractor merely a waypoint on an even larger cosmic current, pulling us towards something infinitely more vast and terrifying, like the even more massive Shapley Attractor beyond it? We are passengers on a spacecraft we cannot steer, moving toward a destiny we cannot see, reminding us that in the grand theater of the universe, we are not observers but participants in a drama whose final act is shrouded in darkness. But if the pull of the Great Attractor is a slow, inevitable tide, the next horror is a sudden, unseen predator in the dark. From a force that tugs on entire galaxies, we turn to a threat that could slip into our own stellar neighborhood without a whisper of warning. These are rogue black holes, the universe's most perfect hunters, and the sheer number of them hiding in the void is what makes them so terrifying. Astronomers now believe that millions of these invisible monsters could be drifting silently through the Milky Way, each one a gravitational vortex of pure nothingness, untethered to any star system and following no set path. Their origin is a story of cosmic violence. Most black holes are thought to be the remains of massive stars that exploded in supernova. But when such a cataclysm occurs in a binary system, where two stars orbit one another, the incredible force of the explosion can act like a cannon, kicking the newborn black hole away at tremendous speeds, sending it flying out into the galactic wilderness alone. Another, even more dramatic theory suggests they are the ancient remnants of the universe's first stars, primordial black holes that have been wandering the cosmos since the dawn of time. Whatever their birth, the result is the same, an object of immense mass and density, cloaked in absolute darkness, moving on an unpredictable course through the galaxy. The true terror lies in their stealth. A black hole itself emits no light. Its presence is only given away by its interaction with other matter. A lone rogue drifting through the empty stretches between stars would be virtually undetectable with our current technology. It would not announce its approach with a bright accretion disk or powerful X-rays. It would simply be a patch of deeper black against the blackness of space, a silent sphere of distorted gravity. By the time we could perceive its effects, it might already be too close to avoid. Imagine such an object, perhaps just a few dozen miles across but containing the mass of several suns entering our outer solar system. Its first touch would be subtle, a slight gravitational nudge. Astronomers might notice a faint, unexplained perturbation in the orbits of distant objects in the Kuiper belt, a few comets shifting onto strange new paths. As it drew closer, the distortions would grow more severe. The delicate orbital ballet of our planets would begin to wobble. Orbits would stretch into ellipses, seasons on Earth would become chaotic and extreme, and the gentle balance that makes our world habitable would be irrevocably shattered. The end would not be a sudden, dramatic consumption, but a slow and inexorable unraveling of everything we know. The black hole would not need to hit Earth to destroy it. Its overwhelming gravity would simply tear our planet apart, stretching and compressing it into a stream of superheated plasma through a process called spaghettification, adding our world to the silent predator's accretion disk. The entire solar system would be dismantled, piece by piece, becoming a temporary halo of glowing debris around an invisible destroyer before it continued on its silent journey, leaving no trace that we were ever here. And the most chilling part of this cosmic horror story, we have evidence that they are out there. Scientists have already identified several compelling candidates. Using a technique called gravitational microlensing, where the gravity of an invisible object bends the light from a background star like a magnifying glass, astronomers have detected unseen, massive bodies drifting through the galaxy. One such object, roughly 7 times the mass of our Sun, was pinpointed about 5,000 light-years away. It is moving at a staggering speed of 100,000 miles per hour. We are essentially living in a forest full of invisible predators, and we have only just begun to hear the rustle of leaves that signals their movement. Yet even the silent, predatory nature of a rogue black hole pales in comparison to a threat that strikes at the very foundation of reality itself. This is not a danger from within our universe, but a flaw potentially woven into the fabric of the cosmos from the moment of its birth. We now turn to what is perhaps the most profound and existential horror on our list, the possibility of vacuum decay. To understand this concept, we must first reimagine the nature of nothingness. We think of a vacuum as empty space, a true void, but according to quantum field theory, what we call a vacuum is not empty at all. It is a seething, bubbling sea of potentiality, filled with temporary particles that flicker in and out of existence. More importantly, this vacuum exists in a state that physicists call a false vacuum. Imagine our universe is like a ball resting in a small valley on the side of a vast, mountainous landscape. The valley is stable for now, but it is not the lowest possible point. There is a much deeper valley far below us. Our entire reality is perched in this metaphoric high valley, and the laws of physics as we know them, the strength of gravity, the speed of light, the behavior of atoms, are all defined by this precarious, temporary position. The horror of vacuum decay is the possibility that somewhere, at any random moment, a quantum fluctuation could provide just enough energy to nudge that ball over the edge of our valley. This would create a tiny bubble of true vacuum, where the fundamental constants of nature are completely different. The laws of physics inside this bubble would be rewritten instantly. The critical, terrifying property of this true vacuum is that it is more stable than our own. Nature always seeks the lowest energy state, so this new bubble would expand in all directions at the speed of light, transforming everything it touches into this new, alien state of existence. The event would be triggered spontaneously and without any warning. It could happen in the deepest void between galaxies a billion light-years away, or it could theoretically happen in the room next to you this very second. The probability is infinitesimally small, but it is not zero. And because the trigger is a random quantum event, there is no cause to predict and no pattern to observe. It is the ultimate cosmic lottery, and the prize is the unmaking of everything. What would we see? Absolutely nothing. The wall of this expanding bubble would be completely undetectable until it reached us. There is no energy release, no flash of light, no shock wave. Information itself cannot travel faster than light, so the moment we saw the bubble would be the exact moment it began to consume us. 1 nanosecond, the universe is normal, the next, and sphere of new physical laws is upon us, and it is already too late. The effect would not be an explosion, but an erasure. As the bubble wall passes through matter, the very rules that govern how subatomic particles interact would be irrevocably altered. Atoms could simply cease to hold together. Protons and electrons might instantly dissolve into new forms of energy. The complex structures that make up stars, planets, and life would unravel in an instant, not through violence, but through a fundamental rewriting of the script of reality. It would be the ultimate cosmic reset button, wiping the universe clean and starting over with a completely new, and almost certainly uninhabitable set of rules. This represents a horror beyond mere destruction. It is the nullification of existence as we understand it. A black hole destroys a planet. Vacuum decay would invalidate the very concept of a planet. It is a threat that reminds us that our universe might not be permanent or stable, but merely a temporary, local configuration in an infinite multiverse of possibilities, and that at any moment, without warning, our particular flavor of reality could simply be switched off. Yet for all its terrifying potential to erase reality itself, vacuum decay remains a theoretical specter, a ghost in the machine of the cosmos. But the next horror on our list is not only confirmed to be real, it has already left its mark on our planet's history. If the universe were to fire a weapon of absolute destruction, it would be a gamma-ray burst. These events are the most violent and energetic explosions known to occur since the Big Bang, and they represent a threat of almost unimaginable scale. A single gamma-ray burst can release more energy in just a few seconds than our own sun will emit over its entire 10 billion-year lifespan. To put that cataclysmic power into perspective, the total energy released would be equivalent to converting the entire mass of a star like our sun directly into pure energy in a blinding flash. But the sheer power is only part of the horror. The true, insidious genius of these cosmic bombs is their design. This energy is not unleashed in a spherical explosion, but is instead focused into two incredibly narrow, counter-opposing beams of radiation that scream out from the poles of the dying system like the beams of a galactic lighthouse, only infinitely more deadly. This focused nature is what makes them so dangerous across intergalactic distances. While a supernova's energy dissipates in all directions, becoming less potent with distance, a gamma-ray burst's energy remains concentrated in a tight beam. If one of these beams were to be pointed directly at Earth, even from thousands of light-years away, it would have devastating consequences. The first sign would be a flash of light in the sky, brighter than any star, even outshining a full moon for a few seconds. But this would not be ordinary light. It would be a torrent of high-energy gamma radiation and X-rays. The initial flash would bathe the day side of our planet in a wave of radiation lethal to any life caught unprotected. But the lasting damage would be even worse. This radiation would violently tear apart the molecules in our upper atmosphere, specifically targeting and destroying the ozone layer that protects all life on Earth from the sun's own ultraviolet radiation. In a matter of seconds, our planet's vital planetary shield would be shredded. The aftermath would be a slow, agonizing death for the biosphere. The surface would be bombarded by intense ultraviolet radiation from our own sun, causing severe mutations in DNA, triggering mass extinctions of plankton and plant life at the base of the food chain, and ultimately leading to a global collapse of ecosystems in a wave of sterility and famine. This is not mere speculation. Many scientists point to a mass extinction event that occurred 450 million years ago, the Ordovician-Silurian extinction, as a prime candidate for a gamma-ray strike. Geological evidence shows a sudden, simultaneous loss of species across the globe, particularly in shallow marine environments that would have been most exposed to UV radiation following an ozone collapse. The pattern of extinction does not perfectly fit other causes like volcanic activity or an asteroid impact, but it aligns frighteningly well with the predicted effects of a nearby burst. What could trigger such an apocalyptic event? There are two primary candidates, and both are common in our galaxy. Long-duration gamma-ray bursts are born from the death of massive, rapidly spinning stars. When such a star collapses into a hypernova or directly into a black hole, the incredible forces can launch those jets of energy from its poles. The other type, a short-duration burst, is even more violent, resulting from the merger of two ultra-dense stellar corpses like neutron stars. These collisions create a newborn black hole almost instantly, and the resulting jets are unfathomably powerful. The chilling reality is that potential progenitor stars for these events exist within the danger zone, a distance of a few thousand light-years. One candidate, WR104, is a binary star system about 8,000 light-years away. It contains a massive Wolf-Rayet star on the brink of collapse, and its rotational axis may or may not be pointed in our general direction. While most astronomers believe we are safe from this particular system, its existence serves as a stark reminder that we live in a cosmic shooting gallery. There could be hundreds of other similar systems we haven't yet identified, their deadly potential hidden in the vastness of space, a silent countdown to a random catastrophe that could begin at any moment, with the flash of light arriving at our planet without any warning at all. But if gamma-ray bursts represent the universe's most furious and concentrated outbursts of energy, the next phenomenon on our list presents us with the exact opposite horror, a profound and terrifying absence. After the overwhelming violence of stellar explosions, we now confront the silence of the Boötes void, a place of nothingness so vast it defies human comprehension. Often called the Great Nothing, this void is a spherical region of space spanning an almost unimaginable 330 million light-years across. To grasp that scale, consider that if you placed our entire Milky Way galaxy, which is 100,000 light-years wide, inside this void, it would be like placing a single grain of sand in the center of an empty spherical room larger than a football stadium. This void is not just big, it is unnervingly empty. In a typical region of space that size, astronomers would expect to find at least 10,000 galaxies, each containing hundreds of billions of stars. Yet within the incomprehensible vastness of the Boötes void, we have found only about 60 galaxies. That means over 99.9% of the expected matter is simply missing. It is a cosmic desert of staggering proportions, a hole in the universe's structure so large that if our solar system were at its center, we would not have known other galaxies existed until the 1960s. The emptiness itself is the monster, a void that swallows light and hope in equal measure. How could such a place come to be? The leading theory points to a process known as hierarchical structure formation, where the gravitational tug of war between matter and dark energy creates vast cosmic webs of galaxy clusters separated by equally vast empty spaces. In this model, smaller voids naturally form and merge over billions of years. The Boötes void could be the result of several smaller voids coalescing into one unimaginably large one, a perfect storm of emptiness. Yet even this explanation feels insufficient for a void of this staggering scale, pushing our models of cosmology to their very limits. This inadequacy of standard models opens the door for more unsettling speculative theories. One chilling possibility involves the vacuum decay we discussed earlier. What if the Boötes void is not a natural formation, but the scar of a catastrophic phase transition? A bubble of true vacuum could have formed in the early universe and expanded at the speed of light, rewriting the laws of physics within its sphere and leaving behind a barren, alien landscape where galaxies simply cannot form. The void would then be a fossilized relic of a universe that once was, a bubble of a different reality that has since stabilized into a permanent and sterile emptiness. An even more speculative and perhaps more terrifying idea is the concept of a Type 3 civilization on the Kardashev scale. Such a civilization would have mastered energy extraction on a galactic scale. The theory suggests that a supremely advanced species might eventually harvest the energy of entire galaxies, surrounding each one with a Dyson sphere or similar megastructure that renders it completely invisible to our telescopes. From our perspective, the galaxies would simply vanish. Could the Boötes void be the territory of such a civilization, a region where every single galaxy has been encased and harvested, leaving behind only the dark, silent husks of 60 galaxies they perhaps found unworthy or left as a preserve? The thought that the emptiness is not natural but engineered is a horror of an entirely different kind. Ultimately, the true terror of the Boötes void is what it represents for our understanding of the cosmos. It is a glaring anomaly that challenges the cosmological principle, the fundamental assumption that the universe is homogeneous and isotropic when viewed on a large enough scale. The void suggests that on the grandest scales, the universe might be lumpy and irregular in ways we do not yet understand, filled with structures and absences that defy our current physics. It forces us to confront the possibility that our corner of the universe might be typical, but a rare oasis in an infinite desert of nothingness, and that the great cosmic game of life may be far more rare and lonely than we ever dared to imagine. Just as the Boötes void presents a terrifying emptiness, another cosmic mystery suggests our universe is being influenced by something even more immense and profoundly alien, something from outside our known reality. Astronomers have discovered that entire galaxy clusters are not just moving, they are streaming in a coordinated, relentless flow toward a specific point on the edge of the observable universe, a phenomenon so unsettling it has been named dark flow. This is not the random drift of celestial bodies. It is a cosmic river pulling thousands of massive clusters along a current that defies all conventional explanation, moving at speeds of over 2 million miles per hour toward something we cannot see. The discovery itself was a monumental shock to the world of cosmology. Scientists were mapping the cosmic microwave background radiation, the faint afterglow of the Big Bang, which serves as a universal frame of reference. They noticed a deeply anomalous signal. The clusters were moving with a velocity and direction that should not be possible. Their motion could not be explained by the gravitational pull of any known structure within our observable universe. It was as if every object on Earth was sliding toward one specific point on the horizon, and when you looked, there was nothing there to pull them. This suggested an unthinkable conclusion. The source of this immense gravitational tug must lie beyond the cosmic horizon, in a region of space-time from which no light has had time to reach us since the beginning of the universe. This idea shatters a fundamental pillar of modern cosmology, the principle that the universe on the largest scales should be isotropic and homogeneous. In simple terms, it should look roughly the same in every direction, and matter should be distributed evenly enough that there are no preferred directions of motion on such a colossal scale. Dark flow is a violent exception to this rule. It points a single, unwavering finger toward a specific patch of sky, implying that our universe is not the uniform expanse we thought it was, but may be part of a much larger and more bizarre structure whose full nature is completely hidden from our view. So what could possibly exert such a titanic gravitational influence from beyond the veil of our observable universe? The theories are as fascinating as they are frightening. One leading hypothesis proposes that the colossal gravitational source is a region of space-time with a density of matter so extreme it defies imagination, a place where the very fabric of the cosmos is contorted on a scale we can scarcely conceive. This could be a vast concentration of mass and energy from the chaotic infancy of our universe, a relic of the inflationary period that was pushed far beyond our horizon, yet whose gravitational reach still extends into our domain like a ghostly hand from the past. An even more radical and mind-bending possibility is that the source of dark flow is not a part of our universe at all. The pull could be coming from another universe entirely, a separate bubble of reality residing in a grand multiverse. In this scenario, the gravitational forces from that neighboring universe are leaking through into our own, tugging on our galaxy clusters from a dimension we cannot perceive. This would mean our cosmos is not an isolated island, but is interacting with other, alien universes with completely different physical laws, and we are feeling the gravitational tide of a reality that is fundamentally other. We are like fish in a pond, suddenly becoming aware of a current that suggests the existence of a vast, unseen ocean beyond our own. The implications of dark flow are perhaps the most profound we have yet encountered. It suggests that the forces shaping the grandest structures of our cosmos operate on a scale so vast that most of the action is happening offstage, in the absolute darkness beyond the reach of our telescopes. It tells us that the story of our universe is not a self-contained narrative. We may be just one paragraph in a much longer book, and the plot twists are being dictated by authors we will never see. The mystery of dark flow is a humbling reminder that for all our knowledge, we are still mapping the shores of an infinite ocean, and the currents we are only just beginning to sense may be pulling us toward a destiny we cannot yet comprehend. After confronting the unnerving emptiness of the Boötes void and the mysterious pull of dark flow, we now turn to a horror that feels almost personal, a betrayal from the very stars we thought we understood. In the cosmic graveyard, not all stars rest in peace. Some refuse to die, rising again in violent, unpredictable ways to haunt the galaxy. These are the zombie stars, celestial monsters that should be cold and dark but instead shine with a stolen, deadly light. The most common of these cosmic undead are white dwarfs. These are the Earth-sized cores of dead stars like our Sun, left to slowly cool over billions of years into black crystalline diamonds. But this peaceful end is often denied. If a white dwarf has a living companion star, a binary partner, its immense gravity can begin to siphon away that star's hydrogen gas. This stolen material builds up on the white dwarf's surface, crushing under its own weight until it reaches a critical temperature and pressure. In a horrifying second life, this dead star core suddenly reignites in a runaway thermonuclear explosion, detonating with such uniform and incredible force that it becomes a Type 1 supernova. This explosion is so bright it can outshine an entire galaxy, and so precise that astronomers use it as a standard candle to measure the vast distances of the universe. The terror of this phenomenon lies in its utter unpredictability and its potential proximity to us. A white dwarf zombie could be lurking in a nearby star system, hidden in plain sight, quietly feeding on its neighbor for millennia before it suddenly reaches its tipping point and explodes. If such an event occurred within a few dozen light-years of Earth, the blast of radiation and high-energy particles would be catastrophic, effectively sterilizing our planet's surface and ending all complex life. The zombie star would not just die again, it would take everything around it with it, but there is another, even more extreme form of stellar resurrection. When a star much larger than our Sun dies, it doesn't leave a white dwarf. It collapses into an impossibly dense neutron star, a city-sized object with the mass of a sun, where a single teaspoon of material would weigh billions of tons. Most of these should simply fade into cold, dark nuggets of degenerate matter. However, some are born spinning at a significant fraction of the speed of light, and these become pulsars, the true vampires of the cosmos. A pulsar is a neutron star that emits beams of intense radiation from its magnetic poles. As it spins, these beams sweep across space like a lighthouse, and if one of those beams points toward Earth, we detect a pulse of energy with metronomic regularity. This clock-like precision hides a ferocious nature. The radiation emitted is a deadly mix of X-rays and gamma rays, and the environment around a pulsar is a maelstrom of high-energy particles. Any planet orbiting too close would be scoured clean by this constant, pulsing barrage, its atmosphere stripped away and its surface baked into a radioactive wasteland. These are not just dead stars, they are actively predatory, turning their local space into a permanent danger zone. The most unsettling quality of these zombie stars is their duality, a haunting mix of the beautiful and the lethal. The same processes that create a diamond core the size of Earth inside a white dwarf are the ones building toward a planet-killing explosion. The incredible clockwork precision of a pulsar that allows us to use them as cosmic navigation beacons is a side effect of its deadly, spinning searchlight of radiation. They are cosmic monsters wearing beautiful masks, reminding us that in the universe, death is often not an end, but a transformation into something far more violent and strange. Yet the universe remains profoundly, unsettlingly silent. We've listened for decades with powerful radio telescopes and scanned the skies for any sign of structured light or megastructures, and we've found nothing but empty static. This glaring contradiction between the high probability of alien life and the total lack of evidence for it is known as the Fermi paradox, and the most plausible solutions to this puzzle are also the most terrifying. One of the most prominent answers is the concept of the Great Filter. This theory suggests that there is some kind of evolutionary or technological barrier that is almost impossible for any civilization to overcome. The development of life from non-living matter, the jump from single-celled to multicellular organisms, the emergence of tools using intelligence, and the leap to becoming a spacefaring species, any one of these steps could be the filter. The horrifying implication is that we might have already passed it, meaning we are the first and only civilization to have done so, destined to inherit a galaxy that is ours alone. But the more chilling possibility is that the Great Filter is still ahead of us. Perhaps the development of advanced technology, like artificial intelligence or biotechnology, inevitably leads to a civilization's self-destruction. Every other species that reached our level of technological sophistication may have already succumbed to its own creations, leaving behind only silent ruins as a warning we cannot hear. We could be naively and cheerfully building the very instruments of our own extinction, marching in lockstep with every other civilization that has ever existed toward a precipice from which no one returns. An even more sinister solution is the dark forest hypothesis. This theory imagines the universe not as a silent graveyard, but as a dark, terrifying forest filled with hidden hunters. The fundamental premise is that the default state between any two civilizations is one of existential threat. You cannot know another species' intentions, and the potential downside of contact annihilation is so absolute that the only logical strategy is to stay perfectly hidden and preemptively destroy any other civilization you discover before it can do the same to you. In this model, every civilization is a silent hunter cowering in fear and ready to strike. The reason we hear nothing is not because the forest is empty, but because everyone is holding their breath, afraid to make a sound. A single stray radio signal or a beacon of welcome could be the equivalent of shouting your location in that dark forest, instantly painting a target on your world for a clean, efficient extermination from a predator you never even saw coming. This hypothesis turns the dream of a galactic community into a paranoid nightmare. It suggests the cosmos is not a place of collaboration but of ultimate competition, where the price of failure is not just defeat, but the complete and total erasure of your species. Those who survive are not the most enlightened or peaceful, but the most ruthless, cautious, and stealthy. Any civilization that is loud, altruistic, or naive would have been weeded out by the universe's ultimate natural selection long ago. The silent darkness of space is no longer empty. It becomes a crowded, terrified, and infinitely dangerous place, where every point of light could be hiding a civilization that has chosen to remain silent not out of wisdom, but out of pure survivalist terror. We are not alone. We are being watched by countless eyes from the darkness, and our continued existence may depend entirely on our continued silence. But if the silence of the cosmos hints at hidden hunters, the very structure of the universe reveals a more immediate and violent reality happening all around us. We now turn to a horror that is not a distant possibility, but an ongoing process of cosmic destruction and rebirth. This is the phenomenon of galactic cannibalism, a predatory dance of gravity and time where the largest galaxies in the universe actively consume their smaller neighbors, and our own Milky Way is both a predator and future prey. The process is both violent and beautiful. When a large galaxy like ours drifts too close to a smaller dwarf galaxy, its immense gravitational field takes hold. The smaller galaxy doesn't simply crash in. It is slowly, methodically torn apart over billions of years. Vast streams of stars, gas, and dark matter are pulled from the victim galaxy, stretching out into long, shimmering ribbons that orbit the predator like cosmic spaghetti. These stellar streams, often containing millions of stars, are the ghostly remnants of past meals, the galactic equivalent of bones scattered around a lion's den. Our own galaxy is currently in the act of several such consumptions. We are surrounded by the evidence of our cosmic predation. The most prominent of these is the Sagittarius dwarf spheroidal galaxy. This small galaxy has been orbiting the Milky Way for billions of years, and with each pass, our galaxy's gravity strips away more of its stars. It has been stretched and pulled so severely that it now wraps around the Milky Way in a vast, complex ring, a celestial serpent eating its own tail as it is slowly digested. Another ongoing feast is the Canis Major dwarf galaxy, which is currently so close that our galaxy's tidal forces are ripping it apart, creating a massive stream of stars that is merging with the Milky Way's own disk. This isn't a rare event. It is the primary way large galaxies grow. We are, by our very nature, a cannibal galaxy, our majestic spiral arms built from the remains of countless smaller systems we have devoured over the eons. The effects of these mergers are catastrophic for any civilizations that might exist within them. As the galaxies interact, gravitational tides disrupt the orderly orbits of stars and their planetary systems. A planet peacefully orbiting its star at a life-sustaining distance could be flung into a new, elliptical orbit that brings it scorchingly close to its star before hurling it into the deep freeze of the outer system, rendering it utterly uninhabitable. Worse still, a planet could be completely ejected from its solar system, thrown into the absolute zero and eternal blackness of interstellar space as a rogue planet, forever cut off from the warmth of any star. Yet from this destruction comes a furious burst of creation. The collisions compress vast clouds of hydrogen gas, triggering intense waves of new star formation. These stellar nurseries give birth to brilliant blue clusters of massive hot stars that light up the galactic landscape, but these new stars are also a double-edged sword. Massive stars burn brightly and die young, exploding as supernovae that bathe nearby space in lethal radiation, potentially sterilizing any fledgling planets that might have formed alongside them. The galaxy is both a life-giving mother and a death-dealing reaper, a cycle of creation and destruction written on the grandest possible scale. And this brings us to the most profound and inevitable galactic horror facing our own home. We are not the ultimate predators. We are also on the menu. The Andromeda Galaxy, our largest galactic neighbor, is on a collision course with the Milky Way. Right now, it is hurtling toward us at a speed of around 250,000 miles per hour. In approximately 4 to 5 billion years, the two galaxies will meet. They will not collide in a single explosive crash. Instead, they will begin a billion-year-long gravitational dance, a slow-motion merger that will utterly reshape the night sky for any future inhabitants of Earth. As the galaxies first approach, the pull of Andromeda's gravity will begin to warp the familiar structure of the Milky Way. The tidy spiral arms will distort and buckle. The serene band of stars we see arching across the night sky will churn into a chaotic mess. Then, as the galaxies pass through each other, their stars are so widely spaced that direct collisions will be exceedingly rare. Instead, the real danger comes from the gravitational chaos. The delicate orbital balance of our solar system will be severely disrupted. There is a small but real chance that the Sun and its planets could be flung out into the intergalactic void, becoming a lonely island of light in an ocean of nothingness. A more likely, yet still terrifying, scenario is that we are thrown into a new, erratic orbit around the newly merging galactic core, passing through regions of intense radiation and dense gas clouds that could threaten our atmosphere. Eventually, the two galaxies will complete their merger, settling into a new, larger galaxy that astronomers have nicknamed Milkomda. This new entity will likely be an elliptical galaxy, a featureless, egg-shaped blob of stars devoid of the beautiful spiral structure we know today. The peaceful, organized galaxy we call home will be gone forever, consumed and reshaped in a violent act of cosmic cannibalism that echoes the very processes that built it in the first place. We are living in a galaxy that is both a devourer and future prey, a temporary arrangement of stars in a universe where the only constant is change, driven by the relentless, hungry pull of gravity. But if galactic cannibalism shows us a universe of predictable gravitational violence, our next horror emerges from the most unpredictable and bizarre realm of physics, the quantum world. This concept is not about an external threat, but a deeply personal and psychological terror woven into the very fabric of reality itself. It is the theory of quantum immortality, and it proposes a fate that could be far worse than simple death. The idea stems from the many worlds interpretation of quantum mechanics. This theory suggests that every time a quantum event occurs with multiple possible outcomes, the universe doesn't choose one. Instead, it splits, branching off into a new, parallel reality for each and every possibility. Every single moment for every single particle, an incalculable number of new universes are constantly being born, creating a multiverse of infinite possibilities where everything that can happen does happen somewhere. Now apply this to your own life and death. Imagine you are in a situation with a statistically high chance of death. Perhaps you are in a plane that is crashing. In the vast majority of the newly split universes, the plane hits the ground and you perish. But according to this theory, there will always be a subset of universes, however improbably, where you survive. Perhaps a freak updraft cushions the impact at the last possible second. Maybe a unique arrangement of debris creates a survivable pocket in those incredibly rare branches of reality you live. Here is where the true horror takes root. The theory of quantum immortality asks a disturbing question: what happens to your conscious experience? Does it follow all the branches, meaning you experience both death and life? Or does your singular stream of consciousness only follow the path, the one single timeline where you continue to exist? If your consciousness is tied solely to the versions of you that remain alive, then from your own subjective point of view, you become incapable of dying. You would unconsciously and completely without choice skip like a stone across the surface of reality, always landing in a universe where you narrowly survive, no matter how absurd the circumstances become. This isn't a superhero's power, it's a cosmic curse. You wouldn't be invulnerable. You would still experience pain, injury, and trauma. You could be caught in an explosion and wake up in a hospital in a universe where the blast was miraculously non-lethal, but left you permanently scarred and disabled. You could be diagnosed with a terminal illness, only to find yourself suddenly in a reality where the diagnosis was a rare administrative error, or where a last-minute experimental treatment works against all odds. With each brush with death, the universe you inhabit would become statistically more and more improbable. The world around you would begin to feel subtly wrong, as the chain of miraculous survivals requires ever more bizarre coincidences and alterations to history and physics to keep you alive. The terror escalates when we consider the very long term. What happens when the sun expands, engulfing Earth? Your consciousness would shift to a universe where, against all known astrophysics, the Earth somehow was not destroyed. Billions of years later, when the universe approaches heat death and all stars fade to black, your consciousness would still persist, finding that one in an infinity universe where entropy has somehow been reversed or delayed, leaving you utterly alone in a cold, dark, and empty void for an eternity, with no possibility of release. You would become a permanent prisoner of your own existence, a ghost trapped in a reality that has no reason to still support life, yet does so only for you. This thought experiment forces us to confront the nature of consciousness itself. Is it a physical process that ends with the brain, or is it a thread that can be severed or continued based on quantum probability? The idea is, of course, untestable and likely unprovable, residing firmly in the realm of philosophy. But its power lies in the existential dread. It evokes the fear that the universe is not just indifferent, but that its fundamental laws might conspire to trap us in a personalized hell of endless survival, where death is not an end, but a door we are never allowed to open. After the unsettling thought experiments of quantum immortality, we descend into a realm where the fabric of reality is not just split, but twisted into a violent cosmic whirlpool. We venture now into the heart of a rotating black hole, a specific and terrifying type known as a Kerr black hole, named after the mathematician Roy Kerr, who discovered the solution to Einstein's equations that describes it. Unlike the simpler, non-rotating black holes we often imagine, a Kerr black hole is not a static pit of darkness. It is a dynamo of spinning space-time, a cosmic maelstrom whose depths hold possibilities far more bizarre and frightening than mere annihilation. The terror begins with its structure. As matter falls into a black hole, it often carries angular momentum, causing the resulting singularity to spin at a significant fraction of the speed of light. This rotation warps the spacetime around it so severely that it doesn't have a single-point singularity at its heart. Instead, the incredible forces mold the core into a ring singularity. This isn't a solid object you could touch, but an infinitely dense, one-dimensional loop where the known laws of physics break down completely. The existence of this ring is the key to its nightmarish potential. Surrounding this ring are not one, but two event horizons, points of no return. The outer event horizon is the familiar boundary from which not even light can escape. But inside that lies a second boundary, the inner horizon, or the Cauchy horizon. This is where the real nightmare begins. The inner horizon is theorized to be a region of infinite tidal forces. While the outer horizon marks the point where you are trapped from the universe, the inner horizon is where the universe might be torn apart for you. Any matter or energy that has ever fallen into the black hole, all the light, the radiation, the atoms of long-dead stars, could be focused and compressed into this one boundary, creating a wall of infinite energy that would instantly vaporize any traveler. This is one potential fate, not a journey through, but an immediate and absolute death by cosmic energy accumulated over billions of years. But let's assume, somehow, a spacecraft could survive passage through this furious inner horizon. This is where physics gives way to phantasmagoria. According to the equations, the unique geometry inside a Kerr black hole could allow for the existence of closed time-like curves. In simpler terms, pathways that loop back on themselves, not in space but in time. A ship traveling along such a path could find itself arriving back at the same point in space-time from which it left. It would become a time machine, but a horrifyingly uncontrollable one. You wouldn't be piloting to a specific date in history. You'd be trapped in a causal loop, perhaps doomed to relive the same moment of entry over and over for eternity, a ghost in a machine of your own making. The most profound and perhaps most terrifying possibility lies with the ring singularity itself. The theoretical models suggest that the extreme warping of spacetime around the ring could create a wormhole, a tunnel, through which a traveler might pass, not into the crushing center of the black hole, but out into a completely different region of spacetime. You might emerge in another universe with different physical constants, in a different time in our own universe's history, or in a distant galaxy millions of light years from home. It sounds like the ultimate adventure until you consider the reality of navigation. There would be no control, no map, and no way to choose your destination. It would be the ultimate cosmic roulette wheel. You might step out into a reality where Earth never formed, where the laws of physics don't allow for atoms to bond, or into the heart of a star the moment it goes supernova. And the journey may not even be a one-way trip. The theories allow for the possibility that these tunnels connect not just 2 points, but an infinite number of them. You could find yourself falling through a series of black holes, each one spitting you out into a stranger and more hostile universe than the last, in an endless, inescapable cycle of existential displacement. You would become a permanent refugee of reality, forever lost in an infinite series of universes. This presents a horror far beyond simple death. It is the ultimate loss of autonomy and context. Your entire history, your loved ones, your planet, your very universe would be gone, replaced by an alien existence with no way back. The Kerr black hole dangles the tantalizing carrot of ultimate discovery before us, only to reveal it as the ultimate trap. It promises answers to the deepest questions of existence, but at the potential cost of everything that makes existence meaningful. It is the universe's most profound and cruelest joke, a door that finally opens, only to reveal an infinite hallway of identical, locked doors with you trapped forever in between. Yet even this menace from deep space pales before a threat that is not cosmic but deeply personal, a danger that targets the very code of life itself. While black holes and supernova unleash their fury across light years, another invisible killer travels at near light speed, silent and relentless. These are galactic cosmic rays, and unlike the dramatic explosions we've explored, this horror is a constant, pervasive drizzle of atomic destruction that permeates the very fabric of space. Imagine the nucleus of an atom, stripped of its electrons and accelerated to almost the speed of light by the unimaginable magnetic fields of a supernova shockwave. This is a cosmic ray, not a ray of light, but a subatomic bullet of pure energy. These particles, mostly protons and the nuclei of heavier elements like iron, are the shrapnel from the most violent events in the galaxy, and they are flying through the void in all directions, saturating interstellar space. Every second, trillions of these microscopic projectiles pass through your body. Here on Earth, we are blissfully shielded by our planet's thick atmosphere and its protective magnetic field, which deflects most of this radioactive barrage. But venture beyond this protective bubble, and you step directly into the firing line. For astronauts, this is a daily and insidious reality. On the International Space Station, crew members are exposed to radiation levels 100 times greater than on the surface of the Earth. A 6-month mission can subject them to the radiation equivalent of over 1,000 chest X-rays. But cosmic rays are far more damaging than medical X-rays. Their immense energy allows them to tear directly through a spacecraft's hull and the human body, not just scattering atoms but smashing directly into the nuclei of our own cells. When one of these high-energy particles collides with a strand of DNA, it doesn't just cause a simple break. It shatters the delicate double helix, creating complex damage that the body's repair mechanisms struggle to fix correctly. This leads to a significantly increased risk of cancer, cataracts, and potential damage to the central nervous system that could manifest as impaired cognition or even early-onset dementia. Long-duration missions to the Moon or Mars would place crews in this radioactive storm for years, making this the single greatest physiological obstacle to humanity's future as a spacefaring species. The threat is not static, it ebbs and flows with the rhythm of our sun. The sun's magnetic field and the solar wind it generates act as a partial shield against these galactic invaders, helping to push them back to the fringes of the solar system. However, the sun's activity follows an 11-year cycle. During the solar minimum, when sunspots are rare and the solar wind weakens, this shield falters. The result is a dramatic surge in the intensity of cosmic rays reaching inner solar system. A future Mars mission launched during this period could face a radiation environment 30% more intense than usual, turning a dangerous journey into a potentially suicidal one. This creates a terrifying window of vulnerability, a cyclical weakening of our local defenses that deep space explorers must carefully navigate. This cosmic assault may have also played a profound and terrifying role in our own planet's history. While our atmosphere protects us from the worst effects, a small fraction of these particles always reaches the surface. Some scientists propose that during periods of a weak magnetic field or exceptionally powerful supernova relatively close to Earth, the flux of cosmic rays could have increased dramatically. This heightened radiation would have acted as a powerful mutagen, bombarding living organisms and accelerating the rate of genetic mutation. While most mutations are harmful, this constant pressure could have forced accelerated evolution, potentially driving the emergence of new species and the extinction of others. We may owe our very existence to an ancient, radioactive rain that scrambled the genes of our ancestors, a game of evolutionary Russian roulette played with cosmic bullets. The implications for our future off-world are dire. Establishing a permanent base on the Moon or Mars means building habitats that can shield colonists from this perpetual fallout. But lead and concrete, the traditional materials used for radiation shielding on Earth, are prohibitively heavy and expensive to launch into space. Future lunar or Martian settlers may have to live their entire lives underground, using meters of regolith, the soil of those worlds, as a barrier against the invisible hail from above, or seek out natural fortresses like lava tubes. Their existence would be one of constant, hidden siege, Living in an environment where a simple walk on the surface without adequate protection would be a calculated gamble with their long-term health. Galactic cosmic rays represent a silent, omnipresent horror, a reminder that the emptiness of space is not truly empty, but filled with an invisible wind of atomic shrapnel, the faint but lethal echo of stellar deaths that occurred millions of years ago. But if the silent drizzle of cosmic rays represents a slow, constant danger, the final horror on our list is the ultimate crescendo of destruction, an end to reality so absolute it makes every other threat seem trivial. After surviving stellar explosions, rogue black holes, and the silent threat of radiation, we must now confront a fate written into the very fabric of the cosmos, a conclusion so violent it would unravel existence itself. This is the Big Rip, the universe's ultimate apocalypse, and its agent is a force we've only recently discovered: dark energy. We've long known the universe is expanding, but the discovery that this expansion is accelerating was a monumental shock. Something is actively pushing space itself apart, and that something is dark energy. For now, its effect is subtle, only noticeable on the grandest intergalactic scales. But the terrifying potential of dark energy lies in its behavior. What if its strength isn't constant? Some models suggest that the density of dark energy could actually increase over time. Instead of a steady push, it would become an ever-strengthening shove, accelerating the expansion of the universe at a rate that grows more and more violent with each passing moment. The timeline of this doom is as methodical as it is horrifying. It begins billions of years from now as the accelerating expansion starts to overpower the fundamental force of gravity. The first structures to be torn apart will be the largest. The cosmic webs of galaxy clusters held together by the immense gravity of dark matter will be the first to snap. Galaxies will be flung apart into the ever-widening void, their stars scattered like dust in a hurricane. The night sky, which today is filled with the faint, dusty light of the Milky Way, would grow progressively darker and more empty as our neighboring galaxies are pushed beyond the observable horizon, their light never able to reach us again. As the acceleration continues, its ferocious grip will tighten closer to home. Gravity within our own galaxy will be the next to fail. The Milky Way's careful spiral structure will unravel. Stars will be ripped from their orbits, sent flying off into the expanding darkness as lone wanderers in an increasingly empty universe. Our solar system, held in place by the Sun's gravity, will be next. The Sun's hold on its planets will be broken. Earth, along with Mars, Jupiter, and all the others, will be flung onto solitary paths into the freezing void, becoming rogue planets adrift in absolute blackness, their sun dwindling to a distant, forgotten point of light. But the horror is only beginning. The expansion of space itself will eventually become stronger than the forces that hold planets together. The same power that is tearing galaxies apart will turn its attention to individual worlds. Earth itself would be torn asunder. The gravitational force that keeps our planet a cohesive sphere will be overcome. Mountains, oceans, and continents will be lifted from the surface and hurled into space as the planet is shredded into a cloud of debris. Then it will target the very bonds of matter. In the final, cataclysmic moments before the end, the expansion will become so violent that it exceeds the electromagnetic force holding molecules together. Every object, every piece of rock, every last remnant of a planet will disintegrate into a diffuse cloud of atoms. And still, the rip continues. In the last fraction of a second, the force will surpass the nuclear strong force, the most powerful fundamental force in nature, the very glue that holds atomic nuclei together. Protons and neutrons will be blasted apart. Atoms themselves will be vaporized into a meaningless soup of quarks and other subatomic particles, ceasing to be matter as we understand it. The end would not be a bang or a whimper, but a silent, ultimate dissolution. There would be no explosion, no energy release. just the infinite stretching of space-time until every point in the universe is isolated from every other point by an insurmountable distance, and all structure, all energy, all potential for life or complexity is forever erased. The universe would become a cold, empty, and featureless void, having achieved a state of true nothingness. This is the Big Rip, not just the death of all things, but the complete and total annihilation of the framework that allows anything to exist at all. A final, absolute victory of expansion over gravity, of emptiness over matter, and of silence over everything. But if the silent drizzle of cosmic rays represents a slow, constant danger, and the Big Rip a distant, theoretical end, there exists a celestial event of such immediate and staggering violence that it makes even a supernova seem almost tranquil by comparison. We now arrive at a spectacle of cosmic destruction and creation so extreme it warps the very fabric of space-time, an explosive dance of the dead that forges the jewelry we wear and could, in an instant, erase all life from our world. This is the neutron-star merger, the universe's ultimate alchemical furnace and one of its most powerful engines of death. To set the stage for this cataclysm, we must first understand the players. Neutron stars are the leftover cores of massive stars that have died in supernova explosions. They are the densest objects in the universe that we can directly observe. Imagine compressing the entire mass of our Sun, a sphere 865,000 miles wide, down into a city-sized object only about 12 miles in diameter. The result is a material so unimaginably dense that a single sugar cube-sized piece of it would weigh as much as a mountain, roughly 1 billion tons. These stellar corpses are so compact that their surface gravity is 200 billion times stronger than Earth's, and they spin at dizzying speeds, sometimes completing hundreds of rotations every single second. The horror begins when two of these ultra-dense objects become locked in a gravitational embrace. Often born together in a binary star system, they can spiral inward toward each other over millions of years, radiating energy away in the form of gravitational waves, ripples in the fabric of space-time itself. In the final moments, their orbital dance accelerates from a stately waltz to a frenzied, fatal pirouette. They circle each other thousands of times per second, moving at a significant fraction of the speed of light, churning the space-time around them into a chaotic storm before they finally collide. The moment of impact is beyond comprehension. The two city-sized objects, each possessing the mass of a sun, slam together. The energy released in this collision is so immense that it makes the combined light of every star in our galaxy seem dim by comparison. For a few seconds, the merger outshines the entire observable universe in gamma rays, becoming what astronomers call a short-duration gamma-ray burst, one of the most energetic events since the Big Bang. But the light show is only a side effect. The true violence is expressed in gravitational waves, sending powerful tremors through the cosmos that we can now detect with observatories like LIGO and Virgo, feeling the echoes of these distant catastrophes as they wash over our planet. This incredible release of energy is both creative and destructive. The extreme conditions inside the merger, temperatures reaching trillions of degrees and pressures far exceeding anything found in any star, act as the universe's ultimate forge. In a process known as rapid neutron capture, or the R process, atomic nuclei are bombarded with a dense shower of neutrons, allowing them to grow explosively heavy in a fraction of a second before they decay into stable elements. It is within these brief, unimaginably violent moments that the universe manufactures its heaviest and most precious elements. The gold in your wedding ring, the platinum in a catalytic converter, and the uranium in nuclear reactors were all born in the heart of a neutron star collision that occurred billions of years ago, blasted out into space to eventually become part of our solar system and our planet. We are literally walking stardust, refined in the most violent furnace imaginable, yet this beautiful act of creation carries with it a terrifying threat. If such a merger were to occur too close to our solar system, the very event that sprinkled our world with precious metals would become an instrument of our absolute extinction. A neutron star merger within a few thousand light-years of Earth would be a terminal event for most, if not all, complex life on our planet. The first and most immediate danger would be the gamma-ray burst itself. The initial flash of high-energy radiation, focused into two narrow jets screaming out from the poles of the merger, would deliver a lethal dose of radiation to any world in its path. If Earth were caught in the beam, the effect would be instantaneous and devastating for the hemisphere facing the blast, but the damage would not stop there. The gamma radiation would rip apart the molecules in our upper atmosphere, specifically targeting and destroying the planet's protective ozone layer. Within days, Earth would be left vulnerable to the full, unfiltered ultraviolet radiation from our own sun. This would trigger a catastrophic collapse of the food chain, starting with phytoplankton in the oceans and plants on land, leading to mass extinction through starvation and radiation poisoning. The sky would glow for days with an eerie, dim red light produced by chemical reactions in the devastated atmosphere, a phenomenon known as a transient luminous event, a constant reminder of the ongoing atmospheric death. Perhaps most unsettling of all would be the arrival of the gravitational waves. Unlike the light, which travels at the speed of light, these ripples in space-time move at the same velocity. If a nearby merger occurred, the light and the gravitational waves would arrive at almost the exact same moment. There would be no warning. 1 second, the sky is normal. The next, it is brighter than 1,000 suns for a few terrifying seconds, and at the same time, the very ground beneath your feet would begin to tremble. Not with the familiar shaking of an earthquake, but with a deep, rhythmic stretching and compressing of the planet itself. The waves would have a frequency that could potentially resonate with Earth's natural vibrations, amplifying the effect. While it is unlikely the waves would tear the planet apart, they could trigger massive, global seismic activity, volcanic eruptions, earthquakes, and tsunamis on an unprecedented scale, adding geological chaos to the atmospheric and radiation horror already underway. The aftermath would be a silent, sterile planet. The beautiful, heavy elements forged in the explosion would eventually rain down on Earth millions of years later, dusting the fossilized remains of a dead biosphere with a layer of precious, worthless gold. The neutron star merger is the universe's ultimate double-edged sword, a necessary event for our existence that, if it comes too close, guarantees our annihilation. It is a reminder that the same cosmic processes that create the building blocks of life also hold the power to snuff it out in an instant without warning, in a blaze of light that outshines creation itself. And yet, for all the colossal energies of colliding stars and the silent dread of the void, perhaps the most deeply unsettling mystery is one of profound and deliberate silence, a single, tantalizing shout in the cosmic dark that was never repeated. In the vast, quiet search for extraterrestrial intelligence, one event stands apart, a 72-second burst of data that has fueled both wonder and terror for decades. This is the mystery of the WOW signal, a radio pulse so perfectly aligned with what we would expect from an artificial, interstellar broadcast that the astronomer who discovered it circled it on the printout and simply wrote, "WOW." In the margin, giving the event its now famous name. The facts themselves are deceptively simple. On August 15, 1977, the Big Ear radio telescope at Ohio State University was scanning the skies, listening for any signal that stood out from the natural background hiss of the universe. Its receivers were tuned to the hydrogen line frequency of 1420 MHz, a wavelength scientists believe would be a logical choice for interstellar communication because hydrogen is the most common element in the cosmos. That night, the telescope's beam passed over a patch of sky in the constellation Sagittarius, and for exactly 72 seconds, the signal's strength surged. It was a narrowband signal, meaning it was concentrated on one specific frequency, unlike the broad-spectrum noise of natural cosmic objects. It followed the exact pattern expected of a distant, fixed source passing through the telescope's stationary field of view. It rose in intensity for 36 seconds, peaked, and then fell away for 36 seconds. It was, by every scientific measure, the perfect candidate for a signal of intelligent origin. And then it was gone, despite decades of repeated, targeted searches of that exact same region of space. Using far more powerful and sensitive equipment like the Very Large Array, the signal has never been heard again. It was a one-time event, a cosmic whisper that vanished as suddenly as it appeared. This singular nature is the core of its terror. A repeating signal could be studied, decoded, understood. A permanent beacon would suggest a desire to communicate, but a signal that appears once and then forever falls silent is a Rorschach test for our deepest cosmic fears, inviting a multitude of terrifying interpretations. The first and perhaps most haunting possibility is that we simply missed our moment. The signal could have been a directed beacon, a focused message from a distant civilization aimed not at us specifically, but swept across our sector of the galaxy like a lighthouse beam. In this scenario, the Big Ear telescope just happened to be pointing in the right place at the right time to catch a 72-second sweep of that beam. By the time we turned our other instruments to look, the beam had moved on, and we were left listening to empty space. The message, whatever it contained, a greeting, a library of knowledge, a warning, is now lost, receding into the void at the speed of light. We had our chance for contact, and it slipped through our fingers, a cosmic missed connection that might not be repeated for millennia, if ever. A more unsettling idea is that the signal wasn't a message at all, but a catastrophic accident. It could have been the final, powerful transmission of a dying civilization. Imagine a world on the brink of extinction, perhaps from a self-inflicted war or an unavoidable natural disaster, firing off one last desperate burst of its accumulated knowledge into the cosmos in a final act of preservation. A message in a bottle hurled into an ocean of stars just seconds before the sender was forever silenced. The WOW signal would then be a cosmic epitaph, a ghostly echo of a people long since vanished, their entire history and essence contained in a burst of data we received but cannot decipher. We are listening to the static hiss of a galactic graveyard, and we briefly heard the last words of one of its inhabitants. This leads to an even more sinister interpretation. The signal was not a greeting or a eulogy, but a warning. A civilization vastly older and more experienced than ours might have discovered some existential threat lurking in the fabric of the galaxy, a spreading wave of vacuum decay, the path of a relativistic kill vehicle, or the approach of a predatory intelligence. They could be broadcasting a focused, repeating alarm to any emerging species they detect, a shout of "turn off your transmitters and hide." If this is true, then our attempts at messaging extraterrestrial intelligence are not a hopeful hello, but the equivalent of shouting our location into that dark forest. Our continued, active listening could be our salvation, hoping to catch the warning we missed the first time, while our own transmissions could be our doom. The most chilling theory of all reinterprets the signal not as a message but as a weapon. A single, powerful, and unrepeated burst is exactly what you might expect from a targeting laser or a scan from an advanced probe. A civilization capable of interstellar travel might use such a brief, focused signal to ping a planet of interest, measuring its atmosphere, its technological output, and its biosphere before deciding on a course of action. The fact that it was never repeated could mean the sender received all the data they needed. In this dark scenario, the WOW signal was not a call. It was a cosmic bullet being chambered, the final sighting shot before a much larger and more permanent silence is imposed. We are left to wonder not about the content of the message, but about the intent of the sender and what their next move might be, ultimately the enduring power of the WOW signal is its perfect ambiguity. It sits at the precipice of a paradigm shift, a single data point that is either the most significant event in human history or a bizarre and unrepeatable natural anomaly, though no convincing natural explanation has ever been found. It is a reminder that the cosmos might be filled with conversations we are not party to, events that flash and fade in an instant, and intelligences whose motives and methods are utterly beyond our comprehension. It is a mystery that refuses to be solved, a silent siren song that continues to pull us toward the stars, forever wondering if we are alone, or if something out there briefly said hello, goodbye, or worse, simply took aim. Yet for all the fleeting mystery of a single radio signal, the universe holds a deeper and far more pervasive secret, a hidden architecture that governs the motion of every galaxy and the ultimate fate of the cosmos itself. This is the realm of dark matter, the invisible scaffolding upon which the visible universe is built, and its presence is the most dominant and most unsettling force in all of creation. We are surrounded by a ghost. Every star, every planet, every atom of visible matter that we can see, touch, and measure accounts for a mere 15% of the total matter in the universe. The other 85% is dark matter, a substance that does not emit, absorb, or reflect any form of light or electromagnetic radiation. It is completely and utterly invisible to our telescopes. We cannot see it, but we know it is there because of its immense gravitational pull. The very fact that galaxies spin at the speeds they do without flying apart is proof that they are embedded within vast, massive halos of this unseen material. It is the hidden hand that shapes the cosmos, a cosmic puppeteer whose strings are made of gravity. The true horror of dark matter lies in its structures. This invisible substance is not evenly distributed. It clumps together under its own gravity, forming an intricate, universe-spanning web known as the cosmic web. This web is the true backbone of the universe. At the largest scales, dark matter forms immense filaments, river-like structures of unimaginable mass that stretch for hundreds of millions of light years. Where these filaments intersect, they create dense knots or nodes. It is at these gravitational anchor points that the familiar, visible universe condenses. Gas is pulled in, galaxies form, and great clusters of thousands of galaxies are born, all tracing out a pattern that was drawn first in the invisible ink of dark matter. We are living in a universe where the stuff we can see is just the decorative icing on a cake whose shape and size were determined by a recipe we cannot read, baked from ingredients we cannot identify. What is this mysterious substance that holds our reality together? The leading theory points to a hypothetical class of particles known as WIMP, or weakly interacting massive particles. These particles would be far heavier than protons but would interact with normal matter only through gravity and the weak nuclear force, making them incredibly difficult to detect. Countless experiments deep underground are searching for the faintest whisper of a collision between a WIMP and an atom in a detector, but so far the silence is deafening. The elusiveness of these particles is a frustration that has led physicists to consider far more bizarre possibilities. Some scientists speculate that dark matter could be made of primordial black holes. These would not be the black holes formed from dying stars, but ones created in the unimaginable density and turbulence of the Big Bang itself. They could range in size from smaller than an atom to larger than a star, a hidden population of ancient gravitational traps wandering the galaxy, their combined mass accounting for the missing gravity. Another theory ventures into the realm of extra dimensions, suggesting that dark matter could be ordinary matter from a parallel universe that is separated from us by a higher dimension. Its gravity could leak into our universe, making itself known only through its pull on our galaxies. This idea suggests we are not just surrounded by an invisible world, but that we are tangibly linked to entire other realities whose matter is forever beyond our perception. The most profound terror, however, is not what dark matter is, but what it does. This invisible infrastructure ultimately controls the fate of every single galaxy, including our own. The immense halo of dark matter that envelops the Milky Way dictates how stars move within it, how our galaxy interacts with its neighbors, and how it will eventually merge with the Andromeda Galaxy. It is the ultimate master of cosmic destiny. Without dark matter's gravitational glue, the universe would be a completely different place. No galaxies, no stars, no planets. The initial expansion from the Big Bang would have scattered matter so thinly that nothing could have ever clumped together to form the structures necessary for life. We owe our very existence to this invisible, unknowable presence. This leads to a deeply unsettling thought about our place in the universe. We pride ourselves on mapping the cosmos, on understanding its laws and our position within it. But the shocking truth is that we are blind to most of the material that makes up our reality. We are like deep-sea fish that have only just begun to theorize about the existence of water. We swim through an ocean of dark matter, unaware of its currents and tides, even as they dictate the entire course of our existence. The universe is not what it appears to be. The majestic spiral of a galaxy is not the main event. It is a fleeting pattern drawn on the surface of a deep, dark, and invisible sea, a sea whose depths we may never truly fathom. But even as we grapple with these existential threats from beyond, a far more certain and intimate doom is written in the very nature of the star that gives us life. This horror requires no alien intervention or random catastrophe. It is a death sentence passed by our own sun, a fate as inevitable as time itself. In approximately 5 billion years, the sun will begin its final, monstrous transformation into a red giant star, and in the process, it will utterly annihilate the inner solar system, leaving no trace that Earth was ever here. This apocalypse does not arrive suddenly. It is a slow, creeping end that begins long before the final act. The sun is a massive fusion reactor, and for billions of years it has been dutifully converting hydrogen into helium in its core. But this process is not sustainable forever. As the hydrogen fuel in the core gradually depletes, the delicate balance between the outward pressure of fusion and the inward crush of gravity begins to falter. To compensate, the sun will start to fuse hydrogen in a shell around the helium-rich core. This new, more vigorous fusion causes the sun's outer layers to expand dramatically and its luminosity to steadily increase. The first signs of this impending doom will be a gradual, inexorable warming of our planet. Over the next billion years, the sun's increasing brightness will begin to disrupt Earth's carbon cycle. The higher temperatures will lead to increased evaporation and more water vapor in the atmosphere, which is a potent greenhouse gas. This will create a runaway feedback loop. As the planet heats further, silicate rocks will absorb more carbon dioxide from the atmosphere, a process that normally regulates temperature but will now spell doom for plant life. With less CO2 for photosynthesis, plant life will begin to die off on a global scale, collapsing the base of the food web and suffocating the atmosphere of oxygen. The oceans will start to evaporate at an accelerating rate, pouring more steam into the air and intensifying the greenhouse effect until the entire planet is shrouded in a thick, oppressive blanket of humidity. Within about 1.5 billion years from now, long before the sun even enters its red giant phase, Earth will have become a Venus-like hellscape. The average global temperature will soar to hundreds of degrees Fahrenheit. The oceans will have boiled away completely, leaving behind a scorched, bone-dry landscape of salt flats and barren rock under a perpetual, searing haze. The atmosphere will be stripped away by the relentless pressure of the solar wind, leaving the surface exposed to lethal doses of ultraviolet radiation. All complex life will have been extinct for eons, and the only remnants of our civilization will be a few faint, fossilized traces slowly eroding under the unbearable heat. The planet will be a preheated oven waiting for the main course of destruction to arrive. That main course begins in earnest around 5 billion years from now. With its hydrogen fuel exhausted, the Sun's core will contract under its own weight, growing hotter and denser until it reaches the incredible temperature of 100 million degrees Kelvin. At this point, a new, more violent fusion process ignites, helium fusion, often called the helium flash. This unleashes a tremendous surge of energy that forces the Sun's outer layers to balloon outward at a staggering rate. The Sun will swell to over 250 times its current diameter. Its surface will cool, turning a dull, ominous red, but its total luminosity will increase thousands of times over. In this monstrous new form, the Sun will engulf the orbits of Mercury and Venus without hesitation. These worlds will be vaporized in an instant, their substance added to the churning plasma of the star's outer atmosphere. The question of Earth's fate is a delicate gravitational ballet. As the Sun expands, it will lose a significant fraction of its mass through a powerful stellar wind. This mass loss will weaken its gravitational grip on the remaining planets, potentially allowing Earth's orbit to migrate slightly outward. Some calculations suggest this could be just enough to keep our planet from being technically engulfed, but this is a hollow victory. Even if Earth avoids direct immersion, it will be orbiting well inside the Sun's tenuous but incredibly hot outer corona. The planet will be bathed in temperatures exceeding 3,000 degrees Fahrenheit, more than enough to melt rock. The surface will liquefy into a global ocean of magma, and the entire world will be stripped down to its core over a period of a few thousand years, its atoms scattered back into the interstellar medium from which they came. The beautiful, intricate, and life-giving solar system we know will be reduced to a few scorched cinders orbiting a bloated, dying star. The Sun's red giant phase is a brief, violent tantrum after a long and stable life, and its final act is to devour its own children, ensuring that the story of Earth ends not with a whisper but with a sizzle. But just beyond the familiar planets and the distant orbit of Pluto lies a far more expansive and unsettling frontier, a vast and silent reservoir of frozen potential. This is the Oort cloud, a spherical shell of icy debris that forms the true outer boundary of our solar system, a region so immense it defies everyday comprehension. Imagine a hollow sphere centered on our Sun, its inner edge beginning roughly 2,000 times farther from the Sun than Neptune, and its outer edge stretching nearly a light-year away, a quarter of the distance to our nearest stellar neighbor. Within this unimaginable volume of near-total emptiness drift trillions of icy planetesimals, leftover remnants from the solar system's formation, each a potential comet waiting for a gravitational nudge to send it on a death plunge toward the inner planets. The true peril of the Oort cloud lies not in its existence, but in its profound instability. These icy bodies exist in a state of delicate gravitational balance, so far from the Sun that its pull is barely stronger than the background tidal forces of the galaxy itself. This makes them exquisitely sensitive to external influences. The primary danger comes from the random, silent passage of other stars through our galactic neighborhood. Every few tens of thousands of years, another star drifts close enough to our solar system to exert a noticeable gravitational pull on these distant objects. As it passes, its gravity acts like a fishing net dragged through a pond, stirring up the water and disturbing everything in its path. It doesn't take a direct hit. Even a near miss by a star many light years away is sufficient to perturb the orbits of countless Oort cloud objects, sending a shower of them on new trajectories that point directly into the heart of our solar system. A second, more constant and insidious influence is the gravitational tide of the Milky Way galaxy itself. As our solar system orbits the galactic center, it doesn't travel on a flat plane. It bobs up and down, oscillating through the dense disk of the galaxy. Each time we pass through the galactic plane, the combined gravity of all the stars, gas, and dark matter exerts a tidal force on the outer Oort cloud, another periodic jostling that can dislodge comets from their stable orbits and set them on a multi-million-year journey toward the Sun. This is a cycle of celestial disturbance baked into the very fabric of our motion through the cosmos, a regular clockwork of potential catastrophe. When one of these distant icebergs is dislodged, it begins a fall toward the sun that can take hundreds of thousands, even millions of years. Slowly at first, and then with gathering speed, it falls inward, a silent and invisible missile on a long-range ballistic trajectory. We would have no warning of its approach until it was already relatively close, perhaps only a few years out, when the sun's heat finally begins to vaporize its ices, forming the glowing coma and magnificent tail that announce a new comet in our skies. By then, if its path intersects with Earth's orbit, it would be far too late to mount any meaningful defense. An object several kilometers across, common in the Oort cloud, striking Earth at tens of thousands of miles per hour, would release energy equivalent to millions of nuclear weapons, triggering a global extinction event not seen since the asteroid impact that ended the age of the dinosaurs. The most terrifying aspect of this threat is its utter randomness and the impossibility of prediction. Unlike asteroids whose orbits we can map and monitor in the inner solar system, the Oort cloud is a dark, uncharted ocean. We cannot see its individual inhabitants, and we cannot know which passing star or which galactic tide has already launched the next planet killer our way. It could be falling toward us right now, and we would remain blissfully unaware for millennia to come. We live our lives in the warm, lighted center of a solar system that is, in truth, surrounded by a boundless and chaotic shooting gallery where the gravitational dice are constantly being rolled, and our long-term survival depends on nothing more than blind statistical luck. But if the silent, creeping doom of the Oort cloud represents a threat from the cold, dark edges of our own system, the next horror forces us to confront a terrifying possibility about the nature of our own existence and consciousness. This is the thought experiment known as quantum suicide, a concept that takes the strange rules of the subatomic world and scales them up to a deeply personal and psychological nightmare. Imagine a diabolical device, perhaps a gun pointed at your head, but its trigger is not pulled by a person. Instead, it is controlled by the random, unpredictable spin of a single electron or the decay of a single radioactive atom, a pure quantum event with a 50% chance of firing in any given second. Now you step into the experiment, the first second passes, the quantum event is measured, and the result is that the gun does not fire, you are alive. The experiment resets, the next second again, the gun does not fire, you are still alive. This process continues second after second, minute after minute. From the perspective of an outside observer, this is a gruesome spectacle of Russian roulette. The odds of surviving 10 seconds are about 1 in 1,000. The odds of surviving a full minute are astronomically tiny, less than 1 in a quintillion. To any outside witness, your continued survival would be a miraculous, near impossible fluke, and eventually the statistical certainty would prevail. The gun would fire and you would die. Your story, from their point of view, would have a very definite and tragic ending. But what is the experience from your point of view? According to the many worlds interpretation of quantum mechanics, every time the quantum event is measured, the universe splits. In one branch, the gun fires. In the other, it does not. Your conscious experience, the thread of your awareness, is tied to the version of you that persists. If the theory holds that consciousness cannot experience its own cessation, then your awareness would always and forever follow the path where you survive. You would never hear the shot, you would never experience death. From your subjective viewpoint, you would simply continue to exist second after second through an ever-lengthening string of increasingly improbable outcomes. The true philosophical horror of this experiment is not the immediate danger, but the long-term implications. As the experiment continues, the universe you inhabit becomes statistically more and more bizarre. To an outside observer, your survival would require a chain of miracles, each quantum measurement yielding the non-lethal outcome against all odds. For you, however, this would simply be your reality. The world around you would begin to feel subtly wrong. Perhaps people would express astonishment at your luck, or equipment would inexplicably malfunction in your favor at the exact moment needed to preserve your life. You would become a walking statistical anomaly, a person for whom the normal rules of probability seem to have been permanently suspended. Now, expand this thought experiment from a single room to a cosmic scale. This is the concept of quantum immortality. It suggests that if the many worlds interpretation is correct, then your consciousness is, from its own perspective, immortal. You cannot experience the end of your own narrative. Any potentially lethal event, a plane crash, a terminal illness, even the heat death of the universe would, from your subjective point of view, simply result in you finding yourself in a universe where you survived. No matter how catastrophic the event, there will always be a branch of reality, however vanishingly small its probability, where some utterly improbable sequence of events allows you to live. Imagine surviving a fatal car crash without a scratch, only to be diagnosed with an incurable disease a year later. As you succumb to the illness, your consciousness would shift at the final moment to a universe where a last-minute experimental treatment worked, or where the diagnosis was a terrible mistake. You would continue on while the other versions of you perish. Over eons, you could find yourself as the last conscious being in a cold, dead universe, your body long since gone, yet your awareness persisting in some form, trapped in a reality that has no reason to support life yet somehow still does, solely because your consciousness requires a universe to contain it. You would be a prisoner of existence itself, cursed to forever experience a world that constantly reconfigures itself to ensure you never, ever die. This idea forces us to confront the nature of reality and our place within it. Is the universe a single, objective reality governed by fixed laws, or is it a multiverse of infinite possibilities where our own consciousness acts as a filter, allowing us to only perceive the timelines in which we persist? The horror lies in the profound loneliness and alienation this could create. Your continued existence would come at the cost of being severed from everyone you ever knew, as their destinies would branch off into countless other realities where they live and die without you. You would be a permanent stranger in an increasingly improbable world, forever wondering if the reality you perceive is real, or merely the one path in an infinite labyrinth that your mind is forced to walk alone for all eternity. After confronting the deeply personal terror of quantum immortality and the silent threats lurking in the Oort cloud, we arrive at a horror that strikes at the very heart of modern science itself, a crack in the foundation of our understanding of the cosmos. This isn't a monster from the void or a distant cataclysm. It is a persistent, growing discrepancy in the data that threatens to unravel our most fundamental theories about the universe's birth, life, and death. This is the Hubble tension, and it suggests that something is profoundly wrong with our cosmic rulebook. The story begins with two different and seemingly foolproof methods for measuring the universe's expansion rate, quantified by the Hubble constant. The first method looks back to the universe's infancy. By studying the subtle patterns in the cosmic microwave background, the ancient afterglow of the Big Bang scientists can determine the ingredients of the early universe and run the clock forward using our well-tested model of cosmology. This predicts how fast the universe should be expanding today. The second method measures the expansion rate directly in the present-day universe. Astronomers use so-called standard candles, like Type 1, a supernova, or pulsating stars called Cepheid variables, whose intrinsic brightness we know. By measuring how bright these objects appear from Earth, we can calculate their distance, and by measuring their redshift, we can see how fast they are receding from us. This gives us a direct, empirical measure of the current expansion rate. The terror lies in the fact that these two methods, which should agree, stubbornly refuse to do so. The early universe method, championed by the Planck satellite, gives us a precise expected expansion rate. The late universe method, refined over decades by teams using the Hubble Space Telescope and other observatories, gives a consistently faster rate. This isn't a small, negligible error bar. The discrepancy is significant, persistent, and growing more confident with each new measurement. It's as if you calculated how fast a car should be going based on the power of its engine and the incline of the road, but when you actually look at the speedometer, it's going noticeably faster. One of our most trusted cosmological tools, the lambda cold dark matter model, is suddenly showing a major flaw. This inconsistency forces cosmologists to confront a terrifying possibility. Our measurement isn't wrong, our understanding of physics is. The Hubble tension isn't merely a problem to be solved, it's a potential portal to new physics, a sign that our universe is governed by rules we haven't even discovered yet. One compelling theory is that dark energy, the mysterious force accelerating the universe's expansion, is not the constant force we've assumed it to be. What if it's dynamic? It could be growing stronger over time, or it could have interacted differently with matter in the past. This would mean the force dictating the ultimate fate of everything is evolving in ways we never anticipated, potentially pointing toward a far more violent and unpredictable end for the cosmos than the gradual fade of heat death. Other explanations venture into even more speculative territory. Could there be previously unknown types of subatomic particles, often referred to as dark radiation, that flooded the early universe and altered its expansion history in a way we haven't accounted for? Or perhaps our universe is interacting with another universe through hidden extra dimensions, a gravitational leakage that is subtly tweaking the rate of expansion in a way that only becomes apparent now, billions of years after the Big Bang. The most unsettling idea of all is that we might be seeing evidence that the fundamental constants of nature aren't actually constant, but have slowly changed over the universe's lifetime, meaning the laws of physics themselves are not the fixed rules we rely on, but are more like shifting sand beneath our feet. The profound implication of the Hubble tension is a cosmic identity crisis. For a century, we have built our understanding of the universe on a solid foundation of general relativity and standard cosmology. This discrepancy is a stark reminder that this foundation might be incomplete. We may be like mapmakers who have just discovered that our entire chart is drawn on a distorted projection, and the true shape of the world is far stranger than we ever imagined. The universe is presenting us with a puzzle whose solution could rewrite the textbooks, not with a new chapter, but with a whole new volume of physics we have yet to conceive. The horror is not in the expansion itself, but in the dawning realization that we are far less certain about the cosmos than we thought, and the truth may be more wonderful and more terrifying than our models could ever predict. But if the quiet dread of quantum paradoxes and the looming threats of the Oort cloud feel abstract, our next horror presents a world of immediate and absolute lethality, a place where the very sky is a weapon. We now journey to the Pulsar Planet, a nightmarish orb orbiting the dead, spinning heart of a supernova, a neutron star that has become one of the most efficient killing machines in the cosmos. These are not merely dead worlds, they are perpetual victims caught in the unending crossfire of a stellar corpse's rage. To understand the terror of these planets, we must first appreciate the fury of their suns. A pulsar is a specific type of neutron star, the ultra-dense remnant of a massive star's catastrophic death in a supernova explosion. This city-sized object, possessing the mass of our own sun, does not fade quietly into the night. It spins, and it spins fast, some completing hundreds of rotations every single second. This incredible rotation, combined with an unimaginably powerful magnetic field, acts like a cosmic dynamo, focusing intense beams of radiation from the star's magnetic poles. As the star spins, these beams sweep across space like the deadly rays of a lighthouse. If one of those beams points toward Earth, we detect a regular pulse of energy, a tick-tock of pure power that gives the pulsar its name. Any planet orbiting this object would be subjected to an environment beyond hostile. The surface of the pulsar itself is a place of impossible physics, with a gravity so strong that any stray asteroid falling toward it would be torn apart and accelerated to a significant fraction of the speed of light long before impact, releasing a flash of X-rays upon collision. But the real danger for an orbiting world is the constant pulsing barrage from those beams. This is not simple sunlight. It is a focused torrent of X-rays and gamma rays, the most energetic and damaging forms of radiation in the universe. This isn't an occasional solar flare. It is a perpetual, inescapable downpour of radiation that would sterilize the surface of any world, shredding complex molecules and scouring the planet clean of any potential atmosphere. The planet would be bathed in a lethal glow, its surface cooked and its very geology altered by the relentless assault. The mystery of how such a world could even form only deepens the horror. A supernova explosion is an event of almost unimaginable violence, a blast wave that should vaporize or fling away any pre-existing planets in the system. The existence of planets around pulsars, therefore, is a cosmic paradox. The first planets ever discovered outside our solar system were, in fact, found orbiting a pulsar named PSRB 1257+12. Their very presence suggests a gruesome second act of creation rising from the ashes of absolute destruction. One leading theory is that these planets are not survivors but ghouls formed from the grave. The supernova may not have completely destroyed all the planets in the original system. Instead, it could have blasted them apart, creating a new disk of debris, a mixture of vaporized rock and metal and exotic matter from the dead star's outer layers that encircled the newborn pulsar. From this disk of destruction, new, second-generation planets could coalesce, their very atoms forged in the heart of a stellar catastrophe. This origin story implies that these worlds would be unlike anything in our solar system. They would not be composed of familiar silicates and iron cores. Their material would be heavily enriched with strange, heavy elements produced in the supernova, like gold, platinum, and uranium. Some scientists speculate they could have surfaces of crystalline carbon, essentially giant diamonds orbiting a dead star. But this astounding beauty would be purely academic, for no human eye could ever behold it. The radiation environment would be so intense that it could create a constant shower of antimatter in the upper atmosphere, leading to bursts of annihilation energy raining down on the surface. The planet's magnetic field, if it even had one, would be locked in a violent struggle with the pulsar's own magnetosphere, generating currents of electricity powerful enough to liquefy rock and create global volcanoes of molten metal. The concept of time itself would be twisted on such a world. With the pulsar spinning hundreds of times a second, the beams would sweep across the sky not in a steady day-night cycle, but in a frenetic, strobing flicker. There would be no rhythm of seasons, no predictable sunrise, only a chaotic, rapid-fire alternation between moments of relative darkness and instants of absolutely lethal brightness. Any potential life that somehow, against all odds, began to form in a protected subsurface ocean would be forever trapped in absolute darkness, its world above a radioactive hellscape, its sky dominated by a spinning, ticking reminder of the apocalypse that created its prison. These pulsar planets stand as the ultimate testament to the universe's indifference, demonstrating that it is perfectly capable of building worlds of astonishing composition, only to immediately place them in an environment so viciously hostile that their existence is reduced to a brief, glowing footnote in the life of a stellar monster. Yet even the violent, ticking death of a pulsar planet and the cosmic inconsistencies of the Hubble tension feel almost mundane compared to a horror that strikes at the very core of physics itself, a paradox so profound it threatens to unravel our understanding of reality's most fundamental rulebook. This is the black hole information paradox, a silent war between the two most successful theories in science, and its implications are more terrifying than any monster or explosion. The conflict begins with a seemingly simple question with an impossibly complex answer. What happens to information when it falls into a black hole? In our everyday world, information is never truly lost. If you burn a book, the ashes and smoke still contain all the information about the book's structure. In principle, with a powerful enough microscope and a perfect knowledge of physics, you could reverse the process and reconstruct the book from the smoke particles. This principle of reversibility is a cornerstone of quantum mechanics. Information it decrees must be preserved. It can be scrambled into an unrecognizable form, but it can never be erased from the universe. Enter the black hole as described by Einstein's general relativity. According to this theory, a black hole is defined by only three simple properties: its mass, its electric charge, and its spin. This is the famous no-hair theorem. It means if you throw a grand piano, 1,000 encyclopedias, and a living elephant into a black hole, the black hole doesn't care. It just gets a little more massive. Its spin might change slightly, but it retains no other memory of what it consumed. All the intricate information about the piano's wood grain, the elephant's DNA, and the words in the encyclopedias is, according to classical physics, utterly and permanently destroyed, vaporized behind the event horizon. This is a direct violation of quantum mechanics, setting up an irreconcilable battle between our theory of the very small and our theory of the very large. The plot thickened with Stephen Hawking's groundbreaking work. He showed that black holes are not completely black. They slowly evaporate by emitting a faint glow of particles now known as Hawking radiation. This radiation, he argued, is entirely thermal and random. It carries no information about what fell in. It's like the smoke from a fire where the specific pattern of smoke particles has no relation to the type of wood being burned. So, if a black hole eventually evaporates completely over trillions of years, leaving behind only this random thermal radiation, then all the information about everything it ever consumed is truly and permanently erased from the universe. This presented physicists with a nightmare scenario. Either quantum mechanics is wrong and information can be lost, or general relativity is wrong and our understanding of black holes is deeply flawed. The implications of information loss are philosophically catastrophic. If information can be destroyed, then the universe is fundamentally unpredictable. The law of cause and effect breaks down. The future could not be calculated from the past because the past would have holes in it, events whose history had been erased. Physics would lose its power. The universe would become inherently unknowable. Its history a book with random pages ripped out and burned, ensuring we could never truly understand the story. This isn't just a problem about black holes, it's a problem about the reliability of reality itself. To resolve this, physicists have been forced to consider some truly bizarre possibilities. One is that the information isn't lost, but is somehow encoded on the surface of the event horizon in 2 dimensions, like a hologram. As matter falls in, its information is smeared across this boundary, and then slowly and encoded back into the Hawking radiation as the black hole evaporates. This holographic principle suggests that our 3-dimensional reality might be a projection from a 2-dimensional surface at the universe's edge, a concept that radically redefines our place in the cosmos. An even more unsettling theory is that of a firewall. If information is to be preserved, the event horizon might not be the smooth, empty space general relativity predicts. Instead, it could be a seething wall of incredibly high energy particles, a literal ring of fire that would instantly incinerate anything crossing it. This would solve the paradox by preventing anything from actually falling into the black hole in the first place, but it would mean our classic image of an astronaut passing peacefully through the horizon is completely wrong, replaced by a vision of immediate and violent annihilation. The most extreme resolution is that black holes don't evaporate completely. a tiny, information-packed remnant might be left behind, a stable speck containing all the data of everything it ever consumed. But this presents its own horror, an entire universe's worth of information compressed into a particle smaller than an atom, a cosmic tombstone so dense it defies all known physics. The black hole information paradox ultimately forces us to confront the limits of our knowledge. It reveals that at the edge of understanding, where gravity and quantum mechanics meet, reality may become something far stranger than we can possibly imagine, governed by rules we have yet to discover, where the very concepts of information and existence are rewritten into something terrifyingly new. Yet even the profound paradoxes of information loss and the violent environs of pulsar planets cannot match the scale of a horror that washes over the entire galaxy in a great, silent wave. From the mysterious heart of our own Milky Way comes a threat that is not a singular explosion, but a prolonged, creeping tide of energy that can reshape the entire galactic environment for millennia. This is the theory of galactic superwaves, a periodic and catastrophic outpouring from our galaxy's core that could reset the clock on cosmic habitability across thousands of light years. Our galaxy is not a static pinwheel of stars, it is a dynamic and sometimes violent system, and its engine room is the central supermassive black hole, Sagittarius A star. While currently quiet, evidence suggests this gravitational monster has had active phases in the past, feasting on clouds of gas and dust. According to the superwave theory, these feeding frenzies don't just produce a flash of light. They can trigger a massive release of cosmic rays and electromagnetic energy that propagates outward through the galactic disk. Unlike a gamma ray burst's narrow beam, this would be a nearly spherical shockwave of energy, a tsunami of radiation expanding outward from the core at a significant fraction of the speed of light. This wave would not last for mere seconds but could persist for thousands of years, a slow-moving wall of energy washing over everything in its path. The effects of such a superwave passing through a region of space would be transformative, as this dense wave of cosmic rays encounters clouds of interstellar gas and dust. The immense pressure could trigger the collapse of these clouds, igniting a firestorm of new star formation. This could explain the mysterious periods of rapid stellar birth we see evidence of in our galactic history, sudden bursts of creation forced by a wave of destruction. The wave would also energize the interstellar medium, causing vast clouds of gas to glow with an eerie, widespread light, fundamentally altering the ecology of the galaxy for any life forms living within it. It is a cycle of death and rebirth on a galactic scale, where a catastrophic event in the core becomes the midwife for new solar systems far out in the spiral arms. For our solar system, the arrival of such a superwave would be an event of existential proportions. Our first line of defense against the galaxy's natural background radiation is the heliosphere, a vast protective bubble created by the solar wind streaming outward from the sun. This bubble pushes against the interstellar medium, deflecting a significant portion of the galactic cosmic rays that would otherwise flood into our planetary neighborhood. A galactic superwave, however, would be a different beast entirely. This immense wall of energized particles and magnetic fields would act like a cosmic piston, violently compressing the heliosphere from all sides. In a very short period, this protective bubble could be squeezed from a sphere extending well beyond Pluto's orbit to a shrunken shell that may not even reach the orbit of Jupiter. Our entire system of planets would be left exposed, thrust out into the raw, unforgiving environment of interstellar space without its primary shield. The immediate consequence would be a dramatic surge in the flux of galactic cosmic rays reaching the inner solar system. Earth's surface would be bathed in a level of radiation unseen since the planet's earliest days. This radioactive rain would have two devastating effects. First, it would significantly increase the mutation rate in all living organisms. While this might drive evolutionary change, it would do so through a terrifying process of mass sterility, cancer, and horrific birth defects, potentially collapsing complex food webs that rely on stable populations. Second, and perhaps more decisively, the increased radiation would profoundly alter our atmosphere. The high-energy particles would knock electrons from atoms, ionizing the air and promoting the formation of nitrogen oxides. These compounds are potent destroyers of ozone, and a sustained assault could shred the planet's protective ozone layer, leaving the surface exposed to the sun's own intense ultraviolet radiation. The result would be a dual-threat extinction event: radiation sickness from below and radiation burns from above. This atmospheric chemistry experiment might have an even more bizarre and chilling outcome. Some climate models suggest that the ionization of the atmosphere could also encourage the formation of high-altitude clouds, increasing Earth's cloud cover and reflectivity. Combined with the ozone loss and the creation of a nitrogen oxide haze, this could trigger a sudden and severe global cooling, a rapid ice age initiated not by a slight shift in orbit, but by a radioactive wave from the galactic center. The climate would seesaw violently between extremes, collapsing agricultural systems and making the planet nearly uninhabitable for a civilization dependent on stable climates and predictable seasons. The most unsettling aspect of this theory is the potential evidence that it has happened before. Geologists have found layers of sediment containing unusual isotopes like iron-60 and plutonium-244, which are forged in supernova and other violent cosmic events. Their presence on the ocean floor and in ice cores suggests our solar system has drifted through clouds of radioactive debris within the last few million years. Could these be the faint, radioactive footprints of a past galactic superwave? Some researchers point to periods of abrupt extinction and climate shift in Earth's history that lack a clear terrestrial cause, wondering if the trigger might have come from beyond our solar system, a silent, invisible wave that washed over our world and left it forever changed. We may be living in a brief, quiet period between these galactic tides, unaware that the core of our own galaxy holds the potential to send another wave of transformation that could challenge the very survival of our species. But if the silent tides of galactic superwaves represent a physical force that could reshape our world, the next horror on our list strikes at the very nature of reality itself, challenging the authenticity of our own consciousness and the universe we perceive. This is the simulation argument, a hypothesis that suggests our entire existence, from the farthest galaxy to the feeling of the wind on your face, might not be fundamental reality, but an incredibly sophisticated artificial construct, a simulation running on some advanced civilization's computer. The core logic behind this idea, popularized by philosopher Nick Bostrom, is a terrifyingly simple trilemma. It starts from a few basic assumptions. First, that it is possible for a civilization to achieve a technological level where it can run vast, conscious simulations of its ancestors. And second, that such a civilization would have any interest in doing so, perhaps for scientific research, historical preservation, or even entertainment. Given these assumptions, Bostrom argues that at least one of the following three propositions must be true. 1. Almost every civilization at our level of development goes extinct before achieving this simulation technology. 2. Almost every civilization that reaches this technological stage has no interest in running such simulations. Or 3. We are almost certainly living in a simulation. Right now, the profound horror of this argument is that the first two options are incredibly bleak. The first suggests a great filter so absolute that no civilization ever survives long enough to create such simulations, hinting that a similar fate of self-annihilation almost certainly awaits us. The second proposition suggests that all advanced civilizations lose the curiosity or the desire to understand their past, or perhaps develop a universal ethics that forbids creating conscious beings in a simulated reality. This paints a future of sterile, disinterested God-like beings, a cosmic loneliness where the answer to "are we alone?" is a depressing yes, because everyone who could be out there has chosen to be. The third option, that we are in a simulation, simply becomes the most statistically likely if you believe that many advanced civilizations would eventually run many simulations. If that's true, the number of simulated minds would vastly outnumber the base reality, biological minds. Therefore, the chances that any given conscious being, including you, is one of the simulated ones is astronomically high. The philosophical terror of this realization is a unique form of existential dread. It means that the laws of physics are not fundamental truths, but merely the parameters of the simulation, the rules of the game. The speed of light, the gravitational constant, Planck's length, these could all be arbitrary values set by the programmers, perhaps to optimize processing power or to create an interesting and stable universe for us to inhabit. It makes our entire scientific endeavor feel like a prisoner studying the patterns on the wall of their cell, meticulously documenting rules that are ultimately arbitrary and could be changed on a whim by the warden. Our search for a theory of everything would be the search for the source code of our own prison. This leads to the ethical horror of being watched. If we are in a simulation, the simulators are, for all intents and purposes, gods. They could be observing our every move, perhaps even intervening in subtle ways. Every miracle, every strange coincidence, every moment of incredible luck or devastating misfortune could be their doing. Our lives become a form of entertainment or a data set in a grand experiment. Our suffering and joy reduced to mere plot points or data points for beings whose motives are completely inscrutable. Are we their beloved ancestors to be preserved and studied with reverence? Or are we merely characters in a game, our lives as meaningful and disposable as the inhabitants of a city in a video game that can be saved, reset, or deleted when the player grows bored? The most immediate and personal fear, however, is the potential for termination or manipulation. If the simulation is an experiment, it could be shut down the moment the researchers get the data they need. If it's entertainment, it could be turned off when the ratings drop. Our entire universe, with its hundreds of billions of galaxies and trillions of stars, could be vanished in an instant with the flip of a switch. Even more disturbing is the possibility of direct manipulation. The simulators could rewrite the code, changing the fundamental nature of reality. They could introduce new laws of physics, create impossible creatures, or even pause the simulation to tinker with it. Our memories, our personalities, our very past could be altered without our knowledge, leaving us as passengers in a reality that is not our own. This brings us to the most tantalizing and frightening question. Could we ever find evidence? Some have speculated that if the simulation is not perfect, it might contain glitches, errors in the code that momentarily reveal the artificial nature of reality. These could explain bizarre quantum effects where particles seem to behave in ways that are not determined until they are observed, as if the program is only rendering reality in detail when someone is looking at it to conserve processing power. Strange statistical anomalies in particle physics or inexplicable constants might be clues, the equivalent of finding a comment left by a programmer in the source code of the universe. Even déjà vu, or moments where the world seems to briefly stutter, could be interpreted not as neurological quirks, but as literal lag or rendering errors in the simulation. Ultimately, the simulation argument holds up a mirror to our deepest fears about insignificance and lack of agency. It threatens to reduce our struggles, our loves, our art, and our greatest achievements to the status of mere information processing in a machine we can never see or comprehend. It is the ultimate cosmic horror, not because the universe is vast and indifferent, but because it might be artificial and managed, making our quest for meaning and purpose the most elaborate and cruel illusion of all. Yet for all the existential dread of simulated realities and the violent crescendo of stellar collisions, there is one ending that stands above all others in its absolute chilling finality. It is not a dramatic explosion or a sudden collapse, but a slow, inexorable fade into silence so complete it erases the very concept of meaning. This is the heat death of the universe, the ultimate victory of emptiness over structure, and the definitive end of all things. To understand this fate, we must first grasp a simple but profound concept: entropy. In essence, entropy is a measure of disorder in a closed system, and the fundamental rule of our universe is that this disorder always increases. Think of it like a hot cup of coffee left on a table. The heat, which is a form of energy, is concentrated in the cup. Over time, that heat dissipates into the room until the coffee and the air around it reach the same lukewarm temperature. The energy hasn't disappeared, it's still there, but it has spread out, becoming diffuse and useless. It can no longer perform any work. The universe is that closed room, and it is slowly and inevitably cooling down. The story of this cosmic ending is written in the life and death of stars. For trillions upon trillions of years, the universe will continue to produce new stars as galaxies slowly consume their remaining reservoirs of gas. But these will be increasingly faint, long-lived red dwarfs, their faint glow a far cry from the brilliant suns of today. One by one, even these embers will eventually sputter and die. The formation of new stars will cease entirely as the last clouds of interstellar gas are either consumed or blown away beyond recapture. The era of starlight, the epoch that made life and complexity possible, will come to a permanent close, leaving the universe in a state often called the degenerate era. What follows is a period of darkness so long it makes the current age of the universe seem like a single, fleeting spark. The galaxies will be populated by the corpses of stars, white dwarfs that will slowly cool into black, crystalline diamonds over tens of trillions of years, neutron stars that will stand as silent, ultra-dense monuments, and cold, barren planets that orbit them in perpetual frozen darkness. There will be no energy sources left to power any form of life or complexity. The universe will be a cosmic graveyard filled with the cold, dead remains of what once was, still orbiting silently in the void. But even this is not the true end. Over timescales that defy human comprehension, the very structures of this graveyard will themselves begin to erode. Through a process called proton decay, a phenomenon predicted by grand unified theories though not yet observed, the very matter that makes up these stellar remnants could spontaneously break down. A proton, once thought to be stable forever, may have a half-life of 10 to the power of 34 years or more. If this is true, then even the iron core of a dead planet, the diamond heart of a white dwarf, and the incredibly dense nugget of a neutron star will, given enough time, simply dissolve. Their constituent protons and neutrons will decay into lighter subatomic particles and radiation, fading away into a thin, featureless haze of fundamental particles spread evenly across an infinite volume. The last great structures to fall will be the black holes. Isolated in the void, they too are not permanent. Through the slow, quantum process of Hawking radiation, they will lose mass, emitting a faint whisper of particles over astronomical timeframes. A stellar mass black hole might take 10 to the power of 67 years to evaporate. A supermassive black hole, like the one at the heart of our galaxy, could take 10 to the power of 100 years. But eventually, even these most powerful gravitational titans will vanish in a final, insignificant puff of radiation. With their disappearance, the last potential source of concentrated energy in the universe will be gone. The final state is not nothingness, but something far more profoundly empty. The universe will have reached a state of maximum entropy, a condition known as heat death. There will still be particles and energy, but they will be spread with perfect, uniform thinness across an ever-expanding void. The temperature will approach absolute zero, a fraction of a degree above the point where all motion ceases. In this state, no energy gradients will exist, no hot spots, no cold spots, no differences of any kind. Without a difference, no work can be done, no stars can form, no chemistry can occur, no thought can arise. Time itself may become meaningless, as with no events to mark its passage, it loses all definition. the universe will be a static, eternal, and utterly featureless sea of equilibrium, a permanent and unbreakable silence. This is the true horror of the heat death. It is not an active destruction but a passive fading. It is the ultimate erasure of all purpose, all structure, and all memory. Every civilization that ever existed, every star that ever shone, every love story ever told, and every tragedy ever endured will be in this ultimate state as if they never were. The universe will have no record of its own glorious and violent history. The heat death renders the entire cosmic drama, from the Big Bang to the last flickering light, utterly and finally meaningless on an infinite timeline. It is the universe falling into a dreamless sleep from which it will never, ever wake. We have journeyed to the very edge of understanding and peered into the abyss, confronting 25 visions of cosmic terror that reveal a universe far stranger and more hostile than we ever imagined. From the immediate, unseen predators like rogue black holes drifting silently through our galactic neighborhood to the apocalyptic fury of a gamma-ray burst that could sterilize our planet in a blinding flash. We've grappled with the eerie silence of the Fermi paradox, wondering if we are alone because the universe is a dark forest filled with hidden hunters, and trembled at the thought of vacuum decay, a random quantum fluctuation that could rewrite the laws of physics and erase reality in an instant. We have witnessed the cannibalistic nature of our own galaxy, a beautiful predator that consumes its neighbors even as it sails toward its own inevitable collision with Andromeda. We felt the invisible pull of the Great Attractor dragging us toward an unseen destiny, and pondered the mysterious dark flow of galaxy clusters toward something beyond our observable horizon. We've stood before the profound emptiness of the Boötes void and considered the chilling possibility that its nothingness might be engineered. We've explored the quantum nightmares of immortality and suicide, and dared to question if our very reality is nothing more than an elaborate simulation. From the lethal radiation of galactic cosmic rays that poses a constant threat to spacefarers, to the ultimate, absolute finality of the universe's heat death, a fade to black so complete it erases all meaning for eternity. Each of these horrors, from the planetary scale to the cosmic, forces a profound shift in perspective. They remind us that our daily concerns, our conflicts, and our triumphs play out on a fragile oasis suspended in a cosmos of unimaginable violence and mystery. We are not the center of the universe. We are a fleeting, fragile moment of consciousness in a grand narrative that is largely indifferent to our existence. Yet, this terrifying understanding is not a reason for despair, but for awe. The fact that we can comprehend these vast and violent forces, that we can measure the spin of a black hole or detect the echo of the Big Bang, is a testament to human curiosity and ingenuity. Every new horror we uncover is a victory for science, a step toward mapping the true nature of the reality we inhabit, no matter how frightening that reality may be. The universe is not obligated to be comfortable for us, and its refusal to conform to our wishes is what makes the quest for knowledge so thrilling. The exploration is far from over. The Hubble tension tells us our cosmological models are incomplete. The nature of dark matter and dark energy remains the universe's greatest secret. Each mystery solved reveals 10 more, and that is the most exciting prospect of all. The cosmos is the ultimate puzzle, and we are only just beginning to understand the questions, let alone the answers. So we turn the question over to you. After this journey into the darkest corners of space, which cosmic horror left you the most unsettled? Was it the silent dread of the simulation hypothesis, the immediate threat of a solar flare, or the existential chill of heat death? Share your thoughts in the comments below. We are truly fascinated to hear what terrifies you most about the universe. If you want to continue exploring these incredible mysteries with us, make sure to subscribe and hit the notification bell. The universe is vast, strange, and filled with stories waiting to be told. We hope you'll join us for the next one.